Let's go ahead and factor the quadratic 9b squared minus 6b plus 1. We're going to use both methods. We're going to do the box method, and I'm also going to show you with rewriting using that middle term as the two terms that we get from the factors. So right off the bat, when you use the boxes, what I want you to see is that the A always goes here, and the C always goes here. These two spots, here and here, are where the terms go that we get from multiplying A times C. So if we multiply A times C, we have 9 times 1. We get a positive 9. I don't want to worry about the negatives yet. Let's just worry about finding factors of 9. We have 1 times 9, and we have 3 times 3. That's it. Now, since this middle term here is a negative 6, we have to understand that in order to get two negatives, a positive factor, and when you add them, you have two negatives, both factors have to be negative. That's the most important part here. Well, a negative 3 and a negative 3, when you combine them, equals a negative 6. Now what we're going to do is we're going to take those two factors and we're going to write them here. It's a negative 3x and a negative 3x. And when we rewrite our expression, we have 9b squared. Instead of writing minus 6b, we're going to use the two factors we came up with. So instead of negative 6b, we are going to have negative 3b minus 3b plus 1. You can see that this stayed the same, this stayed the same. This is the only piece we rewrote. The next thing we're going to do is we are going to scoop into two separate binomials where each of them has two terms, two binomials. If you notice, we also have the same thing right here, except I wrote minus 3x instead of minus 3b. Okay, it's fixed. So we have scooped those up into two separate binomials, and you can see we have what's in our first binomial is the same thing that is right here. So we want to pull out the greatest common factor from this first set. Look at the numbers first. The greatest common factor of 9 and 3. Don't worry about the negative. The greatest common factor of 9 and 3 is 3. They also both have, this has a b squared and this has a b. So remember back from our polynomial unit, when we were factoring polynomials, you looked for the variable with the lowest degree. They both have a b to the first power. Same thing here. We can pull out a 3b. And then you factor it. What is left on the inside? Well, what would you multiply 3b by to get 9b squared? You would multiply by 3b. The same thing here. So 3b times 3b is 9b squared. Now we have to look at that second term right here. What would you multiply 3b by to get a negative 3b? Well, that would be a negative 1. So we have this factor of 3b minus 1. It is also up here. That means whatever we pull out of here is also going to be multiplied by 3b minus 1. So that should also be that factor as well. And remember, when we were talking in class, I said what you end up with inside those parentheses has to be the same. So now we need to factor out the greatest common factor from this lower binomial, which is the same as this binomial right here. Well, what would you multiply 3b by to get a negative 3b? A negative 1. Since this coefficient right there is negative, go ahead and try to pull the negative out first. you have a negative 3 and a positive 1. Well, 3 and 1 are both prime numbers, so the only thing you can pull out is that 1. And let's see if it works. Is a negative 1 times a positive 3b a negative 3b? Yes, it is. Is a negative 1 times a negative 1 a positive 1? Yes, it is. So we know that we have pulled out the correct factors. The next thing we need to do is we need to write it as a product of two binomials. So we have this right here, 3b minus 1, which we get from this and this. So there's 3b minus 1. And then we have the second factor, which is the same thing, 3b minus 1. So really, we have a perfect square here. You can write it like that, no problem, but you're taking one thing and you're multiplying it by itself. So you actually could also write this as the quantity of 3b minus 1 squared. Either way would be correct.